What is beyond the universe? That question itself is wrong. The universe has no outside, because outside requires a boundary. And the universe may not have a boundary at all. 93 billion light-years. That is the radius of the observable universe. But the real universe could be 10 to the 23rd power times larger than that, or even infinite. And we are forever trapped inside this 93 billion light-year spherical prison. Because the speed of light is only 300,000 kilometers per second. Light from farther regions hasn't had time to reach us. Before space itself expanded even farther away, the numbers get even crazier. The expansion rate of the universe is 70 kilometers per second per megaparsec, which means galaxies 14 billion light-years away are receding from us faster than the speed of light. Every single second, space equivalent to the volume of 1,000 solar systems is being created, and we know absolutely nothing about it. Scientists have proposed three possibilities. The first is a flat, infinite universe, like an endless sheet of paper, with no edge, and no outside. The second is a closed universe, like a four-dimensional sphere. If you keep moving forward, you eventually return to where you started. But what does returning to the start even mean in 4 dimensions? Our brains simply cannot imagine it. The third is an open universe, shaped like a saddle, stretching infinitely, but with negative curvature. The most mind-bending idea of all is the multiverse. Our universe may be just one among 10 to the 500th power universe bubbles, each bubble with different physical laws, different speeds of light, different gravitational constants. They float in something called hyperspace. But then the question becomes, what is hyperspace inside of? And that leads to an infinite regress paradox. So what is outside the universe? The answer is, this question itself lies outside the scope of physics. It's like asking, what does 1 plus 1 equal in music? We recognize every word, but together they lose all meaning. But why does it lose meaning? Imagine an ant living on the surface of a balloon. Its entire universe is two-dimensional, length and width only. If you tell it there is space outside the balloon, it cannot understand what outside means. Because in its cognitive framework, the concept of height simply does not exist. We humans are the same. We are trapped in 3 dimensions of space plus 1 of time. When physicists say the universe may be a 4-dimensional hypersphere, our brains cannot construct that image. We can describe it with equations, but we can never truly see it. Just like the ant, it can feel the balloon expanding, every point on the surface moving away from every other. But it can never understand why the balloon expands, because the air inside is a concept that simply does not exist for it. The truth is even more unsettling. Time itself is part of the universe. In 2023, Nobel Prize-winning physicist Roger Penrose showed that time began at the moment of the Big Bang. Before that, there was no before. That word itself is incorrect. It's like asking what lies north of the North Pole. Once you reach the northernmost point, the direction north simply disappears. So when we ask what is outside the universe, we are really asking, what space exists where there is no space? That question is logically self-contradictory, because outside requires space, but beyond the universe, there is no space, and not even a concept of beyond. Yet scientists did not give up. They redefined the question. Instead of asking what is outside the universe, they asked how the universe became what it is today. The answer lies in the inflation theory proposed in 1980. Imagine the first 10 to the minus 35 seconds after the Big Bang, a time so short that, in the blink of an eye, 10 to the 26th power such moments would have already passed. Yet during this unimaginably brief instant, the universe expanded at an exponential rate. Its volume increased by 10 to the 78th power. Within just 10 to the minus 32 seconds, it's like an atom, instantly expanding to the size of the entire Milky Way. This expansion far exceeded the speed of light, but it did not violate relativity, because what expanded was not matter, but space itself. Like blowing up a balloon, the ants on the surface see everyone moving away, yet no ant is actually walking. The surface itself is stretching. This inflation explains a mystery that puzzled scientists for decades. Why is the cosmic microwave background radiation exactly 2.725 Kelvin in every direction? According to common sense, matter from the Big Bang should have been ejected unevenly, with hot and cold regions, but measurements show 2 points separated by 93 billion light-years that have never been causally connected, have exactly the same temperature. The only explanation is, they were once packed together, in the same tiny region, perfectly mixed, before inflation tore them apart to opposite ends of the universe. Like dropping a drop of ink onto a balloon, then blowing it up violently. The ink spreads out, but its concentration remains uniform everywhere. But here comes the even crazier part. The energy driving inflation is called vacuum energy. When inflation ended, it didn't disappear completely. It remained, in a strange new form. That is dark energy. Dark energy makes up 68.3% of the total energy content of the universe. It acts like anti-gravity, causing space itself to repel. The farther apart things are, the stronger the repulsion. That is why the universe is not just expanding, but accelerating. The 2011 Nobel Prize in Physics was awarded to the scientists who discovered the accelerating expansion of the universe. Today the universe is like a runaway train, the throttle stuck, speed increasing faster and faster. One day, this acceleration will reach a critical threshold, when the expansion of space overcomes every binding force. First galaxy clusters will be torn apart, then galaxies, then star systems, and eventually even atomic nuclei. This is the Big Rip theory, but an even lonelier fate is heat death. In the distant future, the universe will grow colder and emptier. The last star will burn out. After 100 trillion years, black holes will evaporate. After 10 to the 100th power years, at that point, the universe will be nothing but darkness and loneliness. Temperatures approaching absolute zero. Nothing will happen forever. Which brings us back to the original question. If our universe really is just one of 10 to the 500th power universe bubbles, where did those bubbles come from? The answer may lie in string theory. String theory suggests the universe may have 11 dimensions. We can perceive only 4 of them. The other 7 dimensions are curled up at the Planck scale, which is 10 to the minus 35 meters, trillions upon trillions of times smaller than an atomic nucleus. The way those 7 extra dimensions are curled determines the physical laws of a universe. Imagine a long pipe. From far away it looks one-dimensional, only length. But if you were an ant walking along it, you'd discover a circular dimension around it. String theory says the universe is like that pipe, except the extra dimensions are so small, we cannot perceive them. In 2003, American theoretical physicist Leonard Susskind calculated that those 7 dimensions have 10 to the 500th power possible configurations. Each configuration corresponds to a different universe. In some universes, the speed of light is only 1,000 kilometers per second. Galaxy structures would be completely different. In others, the gravitational constant is 10 times ours. Stars would burn through all their fuel in a few hundred years. In some universes, atoms could not even form, leaving only a soup of quarks. This leads to a deeply unsettling question. Why does our universe have just the right speed of light, just the right gravitational constant, just the right electromagnetic force, so that atoms can form, stars can burn, and life can exist? The probability is 1 in 10 to the 120th power. Some say this is the design of God, but scientists propose another explanation, the anthropic principle. If there really are 10 to the 500th power universes, then some of them will inevitably support life. We just happen to live in one of them, not because it was designed this way, but because only in such a universe could beings arise. To ask this question, it's like winning the lottery and asking, why me? There is no why. If it wasn't you, someone else would be asking the same question. But there is an even more radical possibility. If our universe is finite, with a beginning, with laws, with precise constants, could it be programmed? In 2003, Oxford philosopher Nick Bostrom proposed the simulation hypothesis. He argued that, if a civilization becomes advanced enough to simulate conscious virtual universes, then simulated universes would vastly outnumber real ones. Statistically, that would mean we are more likely living inside a simulation created by a higher dimensional civilization, like the game worlds we create, only so detailed that even the laws of physics are perfectly reproduced. This idea sounds absurd, yet it explains many strange phenomena, such as wave function collapse in quantum mechanics, why particles exist in superposition, until observed, like on-demand rendering in a video game. A region is rendered only when a player looks at it, or the fine-tuning of the universe. If we live in a simulation, those perfectly calibrated constants may simply be parameters set by a programmer, or the Planck scale. Why does the universe have a minimum unit of length and time? Isn't that like pixels on a screen? Go any smaller, and it stops making sense. But even if this hypothesis is true, it only pushes the problem one step back. Who created the civilization that created us? We are back to the infinite regress paradox. So what is outside the universe? We may never know, not because our technology is insufficient, but because the question itself exceeds the limits of human cognition. We are like ants on the surface of a balloon, unable to comprehend three-dimensional space. We are like characters in a game, unable to touch the world beyond the screen. This is not despair, it is a reminder. the universe is far more mysterious, more vast, more unbelievable, than we ever imagined. Inside this 93 billion light-year spherical prison, we may never escape, but at least we can look up at the stars, we can think, we can ask questions, we can be in awe. Perhaps recognizing our own ignorance is itself a form of wisdom, and having the courage to question the unknown, at the very edge of knowledge, may be the greatest gift the universe has ever given humanity.